My name is Hetal Bosomya and my YouTube channel is Math e-Learning. In this video, we will learn about some basic concepts of Chapter 1 Integers. In this video, you will learn about what is integer, how to represent integers on a number line, some basic facts about integers, and how to do addition and subtraction, how to do multiplication and division of integers, and some properties about integers. First of all, what is natural number? And we know that a collection of 1, 2, 3, 4 up to infinite is called natural numbers. And what is whole number? So it is collection of 0, 1, 2, 3 up to infinite is called whole number. So what is difference between this natural number and whole number? Yes, one additional 0 is here in whole number, right? So we can say that the smallest natural number is 1 and the smallest whole number is 0. What is integer? So we can say that it is a collection of whole numbers and negative numbers. Or you can say that it is a group of 0, positive and negative numbers. We will learn about rational numbers in my upcoming videos. Now what is integer? It is a set of numbers which include 0, positive numbers and negative numbers. It contains 0 and whole numbers. We can denote integers by letter Z, and you can represent using Z as Z is equal to into the brackets -2, -1, 0, 1, 2 and infinite in both ends. Now how to represent integers on a number line? So on the number line, we always represent positive integers on the right side of the 0 and we represent negative integers to the left side of 0, and it is given in this figure. So we can represent 0 in the middle part of this number line and positive integers are on the right side of this 0 and negative integers are on the left side of the 0. And one more thing about 0 is 0 is neither positive nor negative. Now, some facts about addition and subtraction of integers on a number line. If we add a positive integer, we go to the right side on a number line. And one example is also given. In first example, 6 plus 3 is given. So how to do addition of 6 and 3 on a number line? So first we mark on 6. Then after, to add 3, we need to move to the right side. And by moving 3 steps right side, again we mark a number, and here it is 9. So answer of 6 plus 3 is equal to 9. We can directly do the addition. 6 plus 3 is equal to 9. But how to do addition on this number line? For that, you have to move to the right side. Next example is minus 6 plus 3. And we know that minus plus minus. So here we have to do actually subtraction. 6 minus 3 is equal to 3. And sign of greater number, which is negative here. So our answer is minus 3. Now if we want to represent this on a number line, then first we mark minus 6 and then we move to the 3 steps right side. And by moving 3 steps right side, we reach to the minus 3 on a number line. So you can use this way number line to add a positive integer, and for that we need to move to the right of the 0. Second fact is, if we add a negative integer, we go to the left. And we understand using one example. Minus 6 plus minus 3. Now to add a negative integer, we need to move to the left side of 0. So first we mark minus 6 on a number line, and then after we move 3 positions left side, and by moving 3 steps left side, we reach to the minus 9. Third fact is, if we subtract a positive integer, we go to the left. And in this example, minus 4. it is a negative integer, and we subtract positive integer from it. So if we subtract a positive integer, then we have to move to the left. And first we mark -4 on this number line, and to subtract this positive integer 3, we need to move to the left. So we move to the left 3 steps and we reach to -7, and answer is -7. Next fact is, if we subtract a negative integer, we go to the right. For example, -8 minus into the brackets -12, and for that first we mark -8 on a number line, then negative integer -12 is given. That means we need to move 12 positions right side, and we reach to 4, and it is +4. And you can do the calculation like this, and here 12 is minus and subtraction sign is also given, and we know that this minus becomes plus, so it is actually -8 plus 12, and we know that minus plus minus, so 12 minus 8 is equal to 4, and sign of greater number we use in the answer, so it is +4. Next topic is the additive inverse of an integer. The negative of any number is the additive inverse of that number. For example, inverse of +5 is -5, and additive inverse of -5 is 5. By adding the number and its additive inverse, we always get 0. And in this example, it is shown that -5 and its inverse is 5. By adding number and its additive inverse, we always get 0 as answer. The same here. This shows that the number which we add to a number to get 0 is actually the additive inverse of that number. Next topic is properties of integers. You might be heard about closure property, commutative property, associative property, distributive property. right? So all these properties we will learn for integers. So first property is closure property. Closure property under addition, subtraction and multiplication states that the sum, difference and product of any two integers will always be an integer. That means by doing addition, subtraction and multiplication of integers, you will always get integer as answer, right? And one example is given here. These 4 and 5 both are integers, and by doing subtraction we get -1, which is also an integer. Next example is -5 plus 7, and we know that minus plus minus, so 7 minus 5 is equal to 2, and sign of greater number we use in answer, so answer is +2. Next is 6 9s are 54. So by doing addition, subtraction and multiplication of integers, we always get answer as integer. So this is about closure property, and it applies to addition, subtraction and multiplication. Division of integers does not follow the closure property. That means the quotient of any two integers may or may not be an integer. And we understand this with example. -5 divided by -10 is equal to 1/2. And we know that 1/2 is not an integer, right? So this property does not apply to division of integers. It applies to only addition, subtraction and multiplication. Second property is commutative property. The commutative property of addition and multiplication states that the order of terms doesn't matter. The result will be the same. Changing of the order of integers will not change the sum or product. That means this property applies to addition and multiplication. We understand using example. Here 4 plus -6 is equal to -2. Now if we change order of this 4 and -6, then we get the same answer. That means if you change the order of these numbers in addition, the result will be the same. It does not change. Next example is of multiplication, and 10 multiplied by minus 3 is equal to minus 30. And now we change the order of these integers. We take minus 3 in first position, and then after we write 10. And by doing multiplication, we get the answer same. That means if we change the order of these numbers in multiplication, then result will be the same. But subtraction and division are not commutative for integers. That means this property does not apply to subtraction and division. And how? So we can understand using examples. Four minus 6 is equal to 10. Now if we change order of these numbers, minus 6 and 4, then we get answer minus 10. Now compare these answers. Both are not equal. That means this property does not apply to subtraction. Next example is for division, and if we divide 10 by 2, then we get answer 5. But if I change the order of 10 and 2 as 2 and 10, then 2 divided by 10 is equal to 1 upon 5. Now check whether these answers are same. No, both are different. That means if you change order of integers in division, then you will get different answer, not the same, right? That means this property does not apply to division. Property 3, Associative Property. The associative property of addition and multiplication states that the way of grouping of numbers doesn't matter. The result will be the same. One can group numbers in any way, but the answer will remain same. Parentheses, or you can say brackets, can be done irrespective of the order of integers. And here one example is given. One plus 2 plus minus 3. Now this addition is written into the brackets. That means grouping of these two numbers has been done here. And we know that as per board mass, we need to solve brackets first. So we write 1 plus 1 as it is, and 2 plus minus 3 is equal to minus 1. Now 1 plus minus 1 is equal to 0. Now we change the grouping of these numbers. We group this 1 and 2, and for that we write it into the brackets. And then we write plus minus 3. and we solve this bracket first, and 1 plus 3 is equal to 3 and minus 3 as it is. 3 plus minus 3 is equal to 0. Now check whether the answers are same or not. So by changing grouping of these numbers, we get the same result. That means grouping of the numbers does not change the result. That means associative property applies to this addition. Now we check for multiplication. In this example, grouping of 2 and 3 minus 3 is done, and then we multiply with 1. So 2 minus 3 is equal to minus 6. Minus 6 multiplied by 1 is equal to minus 6. Now we change the grouping of these numbers. We take 1 and 2 into the brackets, multiply by minus 3, and 2 ones are 2. 2 minus 3, 2 multiplied by minus 3 is equal to minus 6. Now we check both the results are same or not, and here both are same. That means if you do grouping of any two integers and you multiply it with third number, then the answer, or you can say result, will be the same. Subtraction and division of integers is not associative in nature. That means associative property does not apply to subtraction and division. Subtraction and division of integers is not associative in nature. That means associative property does not apply to subtraction and division. And we understand using example. In this example, grouping of these two numbers is done, and then we subtract answer of this from 1. And 2 minus into the bracket minus 3 is equal to 5, and 1 minus 5 is equal to minus 4. Now we change the grouping of these numbers. We group 1 and 2 here, and 1 minus 2 minus into the brackets minus 3 is equal to minus 2. Now we check both these answers, minus 4 and minus 2 are different. That means associative property does not apply to subtraction. And next example is of division. 6 divided by 4 divided by 2. And now grouping is of 4 and 2. So 4 divided by 2 is equal to 2. And further we divide 6 by 2 and we obtain 3. Now we change the grouping of these numbers. We take 6 and 2 into the brackets, and 6 divided by 2 divide by 4. The remaining number is 4. And first we solve these brackets. 6 divided by 2 is equal to 3. 3 divided by 4 is equal to 3 upon 4. And now we compare this result. 3 and 3 upon 4. Both are different. That means associative property does not apply to division. Property 4, Distributive Property. The distributive property explains the distributing ability of operation over another mathematical operation within a bracket. It can be either distributive property of multiplication over addition or distributive property of multiplication over subtraction. And we understand this thing using one example. -5 multiply by into the brackets 2 plus 1. That means multiplication is distributed over addition. And here we multiply -5 with 2 first. Then after we multiply this minus with 1. -5 multiplied by 2 plus sign, and then after we multiply this -5 with 1. So -5 2s are -10, plus sign as it is. -5 multiplied by 1 is equal to -5. So this is called distributivity of multiplication over addition. Next property is identity property, and here we understand about additive identity and multiplicative identity. First is additive identity. It states that when any integer is added to 0, it will give the same number. 0 is called additive identity. And what is the meaning of this? If you add 0 to any integers, then result is the number itself. That means 0 does not affect the number, right? And that's why we call 0 as additive identity. Next is multiplicative identity. This property states that whenever a number is multiplied by the number 1, it will give the integer itself as the product. Therefore, the integer 1 is called the multiplicative identity for a number. If any integers multiplied by 0, the product will be 0. And we have multiplied this 10 with 1, and we get the result same as the number. That means 10 itself. So we can say that by doing multiplication with 1, the result is the number itself. That means 1 does not affect the number. That's why 1 is called multiplicative identity. One more thing is given here. If we multiply any integers by 0, then the result is always 0. Okay, so remember this thing. Here we have multiplied with 5 and we get product 0. So this is about identity property. Some more facts about integers are given here, and first is, if an integer is multiplied by 0, the product will be the 0, as we have seen in the previous example. Then 0 is divided by any integer, the result will be the 0. Okay, so here in this example 0 is divided by 10 and the result is 0. If an integer is divided by 0, the result will not be defined. If we divide any integers, in this example 10 is taken, 10 divided by 0 is not defined in mathematics, right? So remember these all more properties about integers. And all these properties are covered in this table, and if we go through this table, and here 4 properties are given. This closure property applies to addition, subtraction and multiplication. See, it is not applied to division. Okay, and using this symbol you can understand this means the result of a plus b contains in Z, and it shows that does not contain, right? Then we refer next property, commutative property, and it applies to addition and multiplication, does not apply to subtraction and division. See, it is given here, it does not equal, right? And next property is associative property. It applies to addition and multiplication. It does not apply to subtraction and division. Then distributive property. It applies to addition and subtraction. It is not applicable for multiplication and division. I hope you understand all these properties well, and thanks for watching my video.